In this exercise, we want to figure out the specific activity of an enzyme. So we carry out a series of reactions where we measure the initial rate of an enzyme reaction depending on the substrate concentrations, and from that we determine the maximum velocity of the reaction. So we determine Vmax value, which we have given here as 90 millimolar per minute. And we carry out all the reactions in a total volume of 3 milliliters, and we also use the same amount of enzyme. We have a 5 milligram per milliliter enzyme stock solution, and we use 4 microliter of this solution. So let's remind us what it is when we are talking about specific activity. So specific activity, what does it tell us? The specific activity basically tells us the change of the substrate, change of the amount of substrate in a given time unit, in given time. So that could be per minute, per gram of enzyme. And that is the specific activity. So how can we calculate that? Well, we can break that down into 2 steps. So the first step would be, let's calculate the change of the amount of substrate. So let's calculate the change in the substrate. Change in substrate. And for this, we can very nicely use our Vmax. So we have a Vmax of 90 millimolar per minute. So that would be 90 times 10 to the minus 3 mole per liter and minute. But we don't have a liter, we only have a volume of 3 milliliters. So let's see how much of the substrate changes in these 3 milliliters. So we've got 3 times 10 to the minus 3 liters, that's our milliliter. We see the liters cancel out. And we would get, for the change in substrate, we can write 90 times 10 to the minus 3 times 3 times 10 to the minus 3. And we would have mole per minute. And the reason why I don't calculate that is I don't want to actually do the calculation to avoid any rounding. We just do the rounding then right at the end. So that is the change in the substrate in mole per minute. Now let's calculate the number or the amount of enzyme that we have in our reaction. So the amount of enzyme that we have. And we know that we have 5 milligram per milliliter stock solution. So that is 5 times 10 to the minus 3 gram in 1 milliliter, 1 times 10 to the minus 3 liters. And we use 4 microliter of that. So times 4 times 10 to the minus 6 liters. That is our 4 microliters. And we see that the liters cancel out here. And we can even cancel the 10 to the minus 3 here. So for the amount of enzyme, we have 5 times 4 times 10 to the minus 6, and the unit is this gram here, that is what we have left. So now we have everything to do our specific activity. So our specific activity for the enzyme, specific activity. We put these two steps together. We have the change in substrate, so that would be 90 times 10 to the minus 3 times 3 times 10 to the minus 3 mole. And we divide that by the minute. I just put that down here. Times 5 times 4 times 10 to the minus 6 gram. Now 10 to the minus 3 times 10 to the minus 3, that gives me 10 to the minus 6, and that cancels out quite nicely here. So we have got left 90 times 3, 90 times 3, unit mole divided by 5 times 4, and we've got minute and grams. And that would give us 270 mole divided by 20 mole per minute and gram of enzyme. We can also write this as 27 over 2, so that would be 13.5 mole per minute and gram. But people very often give that in a slightly different unit, so they would write that very often as 13.5 millimole per minute and milligram. We just extend this fraction by milli. So that would be the answer for this question. In our enzyme here would have a specific activity of 13.5 millimole per minute and milligram of enzyme. I hope this makes sense, and thank you very much for watching.